In this video, we're going to look at topic 85, example 2, find asymptotes of a rational function. So there we are asked, how do you find vertical and horizontal asymptotes of a rational function? Part A, what are the vertical asymptotes for the graph of, and then they give us the full function. So take note here, vertical asymptotes can occur at the x values where the function is undefined. Right, determine where the denominator of the rational function is equal to 0. So remember, if you have a fraction and you have a 0 in the denominator, the fraction, that term or expression, will be undefined. So what we're going to look for is we're going to find when our denominator, x squared plus 7x plus 12, is equal to 0. So you set the denominator equals 0. Then in this case, we would look to factor. So I would need factors of 12 that have a sum of 7. So 1 and 12 don't work, 2 and 6, 3 and 4. So 3 and 4 would be my factors. So we get x plus 3 times x plus 4 equals 0. We can then use the zero product property, which tells us that we can pretty much take each piece and set them equal to 0. And now we're going to solve for x. So x equals negative 3. And x equals negative 4. So these two here, x equals negative 3, x equals negative 4, are possible vertical asymptotes. Now we'll get into more detail later about when they're possible but don't actually work. Effectively, if they get canceled out by the numerator. That doesn't happen in this problem, so we don't have to worry about that at the moment. So the next thing you can do is you can actually graph this on the graphing calculator to see if this in fact does work, if those are vertical asymptotes. So I'm going to go to y equals, put your numerator in parentheses, so 3x minus 2, and then we're going to divide by our denominator. Again, make sure it's in parentheses. So x squared plus 7x plus 12. Always check to make sure, see I missed the x here. So check to make sure that you typed the function in properly, otherwise all the work will be for nothing. So 3x minus 2 divided by x squared plus 7x plus 12. So this all checks out. If I graph it, the graph is helpful to a certain point, but what we're going to do is we want to go to the table. So second table, and then we're looking at negative 3, negative 4. So notice how at negative 3, negative 4, there are errors. So that's good news. That does mean that at negative 3 and negative 4, we have vertical asymptotes. So I'm going to draw those in. Might be a little tough to see that there, but we have those vertical asymptotes at negative 3, negative 4. Now we do need to draw the rest of our graph. It would make sense. It doesn't really tell us to, but let's do it anyway. So I'm going to look at negative 6. That matches up with negative 3.3. So that's going to be somewhere about here. Doesn't look perfect. Negative 5, negative 8.5. We'll say that's down there. I don't have any other points, but I know the shape of my graph. So it's going to curve down this way. Then on the other side, negative 2 matches up with negative 4. So that's a little bit easier, or actually, because it goes by tens. Negative 1 is about negative 1, a little bit less. And 0 is pretty close to 0. So we'll have something about there. Again, I know the shape of the graph based on the image that we came up with before. Right? If we go to our graph, we know it looks something like that. Now, notice that we're missing a section between negative 3 and negative 4. If there's a vertical asymptote, there's a good chance there's something between there. So what I'm going to do is I'm going to go to my graph, but now I'm going to hit zoom, and I'm going to scroll down to zoom fit, which is 0, hit enter, and notice that we do have a portion of the graph up here. Now I don't know if that's here, or here, or here, so what I'm going to have to do is I'm going to have to figure out a value in between those. So I'm going to hit second table set, and I'm going to change my change in table to 0.5. All I'm really looking for is a number between negative 3 and negative 4, The 0.5, now if I go to my table, it gives me everything in between those. So everything goes up by 0.5. So I'm going to look for negative 3.5. That'll be between them. That matches up with 50. So that point would be here. And I know based on the graph, the sketch would look something like this. Don't need perfect points. I'm just looking for a sketch of it. So that'll give us kind of the appearance. All right, so that's for our vertical asymptote. Now, moving on to part B, looking at horizontal asymptotes. This is a little bit more detailed. Vertical asymptotes are pretty straightforward. You set the denominator equal to 0, and you solve. You find what x values give you 0. Part B, the horizontal asymptotes, we need to consider 3 cases. All right, case 1 is where the degree of the numerator is less than the degree of the denominator. So this numerator has a degree of 1. So 1 and 2, we compare the degrees. The numerator is less than the denominator. When that's true, when the degree of the numerator, so I'm looking here now, when the degree of the numerator is less than the degree of the denominator, there exists a horizontal asymptote at y equals 0. The reason for that is that as the x values increase, the value of the denominator is going to get much larger at a faster rate than the numerator will. So that means the function is going to approach and get closer and closer to 0. In case 2, again, we're looking at the degree of the exponents, or the degree of the numerator and denominator. So the degree of the numerator in this case is 2. The denominator is 1. So now we have a numerator that is a larger degree. So here, oops. So now here, when the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. All right, so basically what happens is that as the x values increase, again, the value of the numerator is going to get very large in relation to the denominator, and that just means the function is going to continue to increase. There's going to be no horizontal asymptote. And then finally, in case 3, so we had less than, we have greater than. In case 3, that's when the exponents are equal to one another. Okay. And if the exponents are equal to one another, the degree of the numerator and the degree of the denominator are the same, the horizontal asymptote is the ratio of the leading coefficients. So the terms or the exponents that you were just looking at, the terms that those come from, in this case, we had y, actually let me write that in here, sorry about that. We would have y would be equal to 2 over 1. And that 2 is from here, the 1 is from here. We're taking the coefficients. Now you could obviously reduce that to 2, so you would have a horizontal asymptote of y equals 2. In case 3, again, when the exponents or the degrees are equal, you take the coefficients, right, the leading coefficients, and that will be your horizontal asymptote. So if we go back to our original problem, f of x is equal to 3x minus 2. We have a degree of 1 in the numerator. My denominator is x squared plus 7x plus 12. So if I look at the degrees of my numerator and denominator, the numerator is less. That's case 1. Now you don't need to memorize the cases. I'm just using this to reference it. So the numerator is less than the denominator. That means that there is a horizontal asymptote at y equals 0. Again, you don't need to memorize the cases. I'm just always going to reference them so we can go back to our notes and know which one we're talking about. So the horizontal asymptote would be y equals 0. If we go back to our graph, either on the calculator or the graph that we drew above, notice that my left and right sides of my function do approach 0. They approach that horizontal asymptote. So it checks out in this case, and that's really it. It is a little detailed. You will need to do some work and take a lot of time practicing this to really get the hang of it. But ultimately, your vertical asymptotes, you're setting the denominator equals 0. There will be a lot of factoring involved there, so you need to make sure you brush up on your factoring. And the horizontal asymptotes, you have to consider these 3 cases. You just need to recognize them. Fortunately, there's only 3 that you need to remember. And if you're a little bit better at math and understanding how numbers get larger and smaller in relation to one another, these cases actually will make a whole lot of sense. So try the try-it problems, see how you do with those. They're not asking you to graph these ones. just come up with the vertical and horizontal asymptotes.